Good evening, everyone. Today's day 9 session, uh, introduction to mobile app security. Okay, follow the WhatsApp channel for further updates. Let me introduce myself. Myself is the Vogler Peter Aseria, who's a junior pentester in BCBUZZ Technologies. Today, I'm going to take session of Android mobile application security, but in mobile application security, I'm going to particularly take Android security, Android application security. Um, These are the certifications I had completed till now. There are totally 17 certifications I completed. Okay, before starting the session, I'm going to make note about disclaimer that put a disclaimer that uh, about the legal consequences. Don't try this at home without any proper instructions or proper authority. Okay, uh, get an NDA signed, non-disclosure certificate, then do this. Otherwise, don't do this. This because legal consequences will be taken place. Let me start. Let's start the session. First, first we look out after the Android architecture, because before we go into practical session, first Android architecture we need to know what is Android and how the applications are running in the background and how much layers are totally there in the Android applications between the application and the mobile phone. So how an hacker used to hack each layer and get the information what they required. First, before practical, we need to know what is application Android architecture. So there are totally 5 layers of Android architecture. The first layer is application layer. Uh, application layer. Application layer is the top layer of the Android architecture. This layer is like the pre-installed apps like camera, calendar, Google Play Store, or third-party apps also like Instagram, Facebook, and etc. These applications which we install in our Android mobile phone is called as application layer. This is the top layer used to user interaction between user and Android mobile phone. So this layer is to communicate to the second layer called application framework. Application framework is a layer used for the application communicate with application framework, such as for some from accessing the allow access concept, such as if an app you are using Gmail application, you need to know the who sent mail, notify you who sent the mail. The notifications comes on the top priority. This is the with this help. This comes with the help of the application framework layer. So when application is application framework, when in a notification or not only notification, any other access uh, security logs, activity logs, not security logs, activity logs, and etc. Managing files, etc. Are monitored by this application framework layer. Android runtime. Android runtime is like running of application behind the application framework layer. It's used to Android and is used to create a virtual machine called Dalvik virtual machine. This the previous I'm talking about the till Android version 9, the Pi version. The Android runtime used to create a virtual machine and Dalvik virtual machine. After 9 is used to create a Java virtual machine. Before 9 used to create a Dalvik virtual machine to run the application in background, uh, run the application framework, such as it will to communicate with Linux kernel. now after the application after the version 9, they are using Java virtual machine. Before they are using Dalvik virtual machine. After using Java virtual machine, but the concept is similar. Because why they are using Java virtual machine? Because nowadays apps are created in two applications are created in developers are created in Java or Kotlin. These two programming language used to create the application. So the Linux kernel needs to know which Linux kernel needs to know which uh, the communication between the Linux kernel and the application. So if for example application is running in Java, but Linux kernel is running in some other language, C language. The Java cannot be compiled in C language. So the both need to communicate. So this by Android running time creating a Java virtual machine, the both can communicate and run the background processes. Platform libraries. Platform libraries are included in C and C++ program. Used to these platform libraries are created by Android developers. The issue main purpose is similar to Android runtime, used to communicate both the language. It's a bridge. It's a like API to both the application and the Linux kernel. Uh, such as it's between the communication between the if Instagram is if we open Instagram, we need if we want to upload a photos or videos in Instagram, we need to access the library and take the photo and upload it to Instagram. So for the application layer is mostly run in Java, but the platform libraries are run in C++. This method, the virtual DVK method or DVM method or JVM method, the both the programming language used to communicate and transfer the file, and we can upload the file photos from the library to the Instagram. So not only for media, for some kind of SQL database, web link, and everything, SSL secure circuit. For everything, we are this platform library is important thing. Kernel, Linux kernel. Linux kernel is the heart of Android architecture because it's used to interact with the hardware devices in the Android mobile phone uh, and mobile phone. Linux kernel is not like Linux OS. Linux kernel is different from Linux OS, and Linux using Linux kernel only the application layer used to communicate to application architecture, application framework, and application runtime. Then it will communicate with the Linux kernel to power on the if you need to turn on the Bluetooth. The application if you give a command in the screen, the Linux kernel will give the command to Bluetooth driver to turn on the Bluetooth device. Such way you can connect any other Bluetooth devices. Not only for Bluetooth devices and other devices also. The Linux kernel is the most important thing to open to enable cameras, Bluetooth, and etc. The and it manages the power management also. Uh, giving out is need to turn on the power and etc. Features of Linux kernel. Security. Linux kernel can handle security, the applications and the system. See, if we bypass the Linux kernel, we can bypass the application and we can remove law protections That means the screen lock, and we can transfer file and etc. if we compromise the Linux kernel. So Linux kernel gives security. It manages the memory. If we want to install an application in Android mobile phone, we the Linux kernel needs to give permission, and it's allocate the application to install in the storage device that is present in the mobile application, mobile phone. And process management, it process and allocate resource process whenever they need them. If if we if you're running Instagram and you need to open WhatsApp, the the Linux kernel will change the path of from Instagram to WhatsApp in a fraction of seconds, where the change of path is used by Linux, done by Linux kernel. Network stack and driver model. The hardware's drivers such as Bluetooth driver, camera drivers, every drivers are installed in Linux kernel such way the application can run the the Bluetooth or the necessary drivers that are built in Linux, that are built in mobile phones. Okay, let me move on to hands-on demo how to exploit the Android Android mobile phone. And for this setup, I'm using Android 9, the 5 version. That is a vulnerable machine. So I'm going to bypass the screen lock and get the root access to the root privilege, and going to put a ransomware in that application. Okay, let me move to that session. First, I'm going to boot up Android in a virtual environment. So virtual player, opening virtual player. Start and restoring session. Okay, I opened Android environment and I'm going to set the screen password. Okay, then I'm going to reboot this device. Now I'm going to boot the Android 9 Pie edition. But before that, I need to give E to edit some text because don't boot up. It not want to manually configure that booting structure. Now give no mode set expose rasa, then give enter and give B to boot the Android 9. It will take a few minutes to boot up because we are running giving only 3 GB of RAM to this configuration. So it will be a little slow. And disclaimer that don't try this at home with any other Android device running on Android 9 because it's not legal. If you want to try this, you want to learn this, please try with your own lab environment. Create virtual machine like me, or use your own mobile phone, not any other's mobile phone, and try this at your home. Sorry for the inconvenience. And it is taking time to boot it up. Please be patient. Okay. For booting up, I'm going to share some information about it. This Android version 9, so it's vulnerable. But if you are trying in an Android version 14, it is secured. So we cannot use this methodology in Android version 14. Uh, and now this lab we majorly use of ransomware also. We're going to try exploiting the ransomware in the Android version 9. If person unauthorized, if anyone clicks a link or installs an app, it will lock the screen and we need to set the password to remove a password to access the data. So by this method also, this two method, we're going to remove the password protections and we're going to use ransomware and we're going to get a metaprotect session using metasploit also to transfer data from our system to the victim system or from victim system to our system. Both vice versa, we can do that. So uh, these three things actually we are going to do is some kind of errors right conducting right now. So please be very patient. I think so it will boot it up within a minute. due to technical error, we are going to reinstall the Android device, Android OS, and we're going to configure that file, and we're going to exploit this thing. First, we downloaded the ISO file of the Android 9 version, and we're going to add it to virtual machine, which we are using VMware Player. First, you have to use select the ISO. And click next. It's Linux, so I'm going to give next. Pathway, give the name Android 9 version 9, and give next. Go into a storage single device and give next, and customize hardware and give RAM up to 3 GB or 4 GB. Again give finish. Now first give the first option, advanced option, and give auto install run specification. Give yes. It's now is writing on the file. Give virtual machine, remove device, and give CD DVD SATA, and give yes. And then we need to run reboot. Now give E, again E. Then we need to, as the previous step, we need to edit that quiet and write no mode set X force versa and enter B to boot the setup. Now that menu we need to press Alt F1, such we get the console menu. Now we're going to create a directory, make directory such as mount SDA, MNT is the mount, and mount SDA, and give mount dev slash black slash SDA1 slash MNT slash SDA1. Yeah, we will remove one and give enter, it will be mounted. Now since vi slash gov, vi slash nmt slash SDA slash gov slash menu slash menu dot list. Okay. Now give reboot, it will restart the. Now we have to press WE, then edit the quiet and the same process, right? And write mode and X force versa and enter B. This is the process of installing Android version in VMware. Now you start setup Wi-Fi, but we are connect with the bridge to adapt bridge, so you don't need to give anything. Already it will allocate, and it will auto config the IP address also. It will take a few moments. It's checking for updates and the same process of installing the start up a Android mobile phone. Now give don't copy. Now we give it skip. Accept terms and conditions. Pattern. I'm giving one pattern. That's all the first steps. Now it will open. Okay, it started up. Now we're going to check the IP address that is located in this machine. We are going to settings, network, Wi-Fi, advanced. Okay, IP address is 192.168.31.20. Okay, we know the IP address. Now we're going to open terminal and we're going to connect. First, we need to switch to root user. So we are using sudo su, but it's already in root user, so we don't need to do that. First, we check our IP addresses. IP address, it's this, but vnet 8 is the IP address allocated for the Android versions 9. Now we're going to check devices, what are ADB devices that are connected to this machine. Now I'm going to turn on the builder settings. If the builder setting is not on, we cannot get access of the Android device. So we are going to turn on the builder. This is important. So in your Android device, you shouldn't turn on this developer mode. If you turn on, you can easily get access by hacked by a hacker. So it is important you don't turn on this developer mode. Now we're going to terminal and dbd connect this. First, we're going to scan using enough scan the IP address. Okay, we found port 555 TCP is open. The ADB service is running. So this method we're going to connect to that Android device using ADB connect. So we are going to give ADB connect, the IP address, and the port number. Okay. The only developed if the Android is developer mode, you can connect. Otherwise, it won't be able to connect. And this port number won't be shown in the nmap scan results also. So now we're going to get the root access. So by giving the this command, we get connected to this device, and now we're going to check the packages that are available in that Android machine. Okay, these much services are running in that Android machine. That they pre-inbuilt tools. The we can take the Bluetooth, wallpaper, contact, etc. Many things are there in this. These are pre-installed tools in Android application. See Android version 9. Okay, now we are going to remove the pattern that the screen pattern. So first we are going to give ADB shell and give UMI its shell access. Now we are going to change to root access. So we are going to give SU. SU we got the root access. Because it is in develop mode, we easily get the privilege escalation and we got the root access. If it is not in this, we need to want to privilege escalation methodology also. Now we are going to remove the pattern lock, the screen lock that is in the Android machine. So by giving remove data system lock settings dot db star and enter. Okay, before removing that, we are going to check the file is available in that Android application, Android device. So, okay, we got that that kind of file is available in that Android application. Now we are going to remove that application such way and give okay, there are no files are there in this. Okay, by giving this command, the every log database, the screen pattern database are saved in this particular directory or file. It's been deleted such way if we reboot the system, then when we can log in to the uh, machine without any pattern. So background you can see that it is rebooting. Giving the same commands to start the machine. Okay, okay, it got started. Now this time no issues have been taken place. Now see, we can go inside without any pattern. See the data store, the patterns data stored in that particular directory is removed. So we can go inside and the device without any pattern, and we can bypass the authentication pattern authentication. Now this one method we have done. The second method we are going to do is Meterpreter. We're going to get a Meterpreter session using MSF Venom and Metasploit. First, we're going to create a we're going to start the MSF console. Okay, before running this Meterpreter session, we need to create a payload using MSF Venom. But right now I am having that payload. But for your reference, I am going to show that the terminal command, and this is the command used to create the payload. By giving MSF Venom -p stands for payload, Android slash Meterpreter slash reverse TCP. Reverse TCP is going to get the reverse connection from the TCP port. That is triple five. Now, this scenario is the 4 times 4 using the IP address that this machine's IP address. Uh, this machine IP. This is local LHOST stands for local host, and this attacker's machine IP address. So press enter. Actually I am having evil.apk1 file, so I'm using evil1 as we can use as per our wish. Okay, now we are going to push the payload to the uh, connected ADB port using adp install evil.apk. So it will ask for to want to install, we give install anyway. The application will be installed in background. To check that we can get a success message. Yes, we got the success message. So if this application is installed, and we need to check it once it is installed or not. See, main activity and application additionally is installed. That is the application we installed right now. Now we need to open a multi-handler in MSF console. Use 7 and so options. We're going to set lhost, lport, and the payload, which payload you are going to use. Android slash Meterpreter slash reverse TCP Meterpreter P and Meterpreter TCP. Then we are going to give a check once again. Every option we are given as right. Okay. Okay, everything is done. So we're going to give exploit. The okay, the TC port handler is listening. Now we're going to the Android application and going to click it on. See, we got the Meterpreter session. We got access to the Android. Then we can see the Android version 9 was running in Linux kernel. We can get root user also, but it's a this is a education purpose. So we are doing it for education purpose only. So we are not getting root access in the Metadata session. If we got the root access in Metadata session, we can we can screen share also. You can see what application they are doing, what they are doing. We can see live, similar in our screen also. So right now we are going to not taking the session. These are the commands we will we can use in Metadata session. We can check root access, dump call logs, dump contact, dump SMS, etc. We can do any action as per our wish. So, doing you want to for learning this, you need to do in your own lab environment. Don't try to do any other environment. Okay. Still for now, any doubts are there? You can ask me right now. So I'm going to end this session. Thank you for your questions.